Ever pondered about the possibility of journeying through the cosmos in a blink of an eye? Let's immerse ourselves in this thought-provoking question for a moment and dive headfirst into the fascinating realm of wormholes. Wormholes, as you might know, are cosmic shortcuts, a theoretical passage through space-time that could create links between impossibly distant regions of the universe. From the imaginative minds of science fiction authors to the chalk-covered blackboards of theoretical physicists, the concept of wormholes has always stirred a sense of wonder and curiosity. These hypothetical tunnels, etched into the fabric of the universe, could potentially offer us a path to the farthest galaxies, opening up a universe of possibilities. But are these just flights of fancy, or could they truly exist? Could we, the inhabitants of a tiny planet in the vast cosmic ocean, ever harness the power to create such a celestial superhighway? Imagine we could create a wormhole, a gateway to another galaxy. What then? The birth of a wormhole is no ordinary event. It's a phenomenon that takes us deep into the realm of theoretical physics. To understand wormholes, we need to take a quick dive into the world of Albert Einstein, the man who revolutionized our understanding of the universe. In the early 20th century, Einstein proposed his theory of general relativity. This groundbreaking theory suggested that space and time are not separate entities but are woven together into a four-dimensional fabric known as space-time. Now, imagine this fabric as a trampoline. When an object with mass, like a bowling ball, is placed on it, it curves or warps the fabric around it. This warping is what we perceive as gravity. Now let's get to the exciting part. Einstein's equations also suggest that if space-time can be warped, it could also be twisted and folded to create shortcuts, which we call wormholes. These theoretical passages could potentially connect two distant points in the universe, making interstellar travel feasible. But how do we give birth to a wormhole? Here's where things get a little tricky. To create a wormhole, we would need something called exotic matter. This is a type of matter that has negative energy density and large negative pressure. The role of this exotic matter would be to counteract the natural tendency of a wormhole to collapse under its own gravity, keeping the passage open. However, there's a catch. The energy required to create a wormhole is immense, equivalent to the energy of a star. Moreover, we would need to maintain incredibly precise conditions to keep the wormhole stable. Any slight fluctuation could see the wormhole collapse, potentially causing a catastrophic event. So, while the idea of creating a wormhole and traversing the cosmos sounds like a thrilling prospect, it's not without its challenges. It requires a deep understanding of the universe's fundamental laws, a colossal amount of energy, and conditions that are beyond our current technological capabilities. With such immense energy and precise conditions, creating a wormhole seems like a Herculean task, doesn't it? Embarking on a journey through a wormhole is like diving into the unknown. We're talking about a cosmic shortcut, an interstellar tunnel, a portal to another part of the universe. It's an exhilarating concept, isn't it? But as exciting as it may sound, the journey is fraught with potential dangers and challenges. Imagine, if you will, the extreme gravitational forces at play as we traverse this wormhole. The gravitational pull could be so strong that it would tear apart anything that ventures in, from a spaceship to an atom. Now that's a ride you wouldn't want to take. Then there's the issue of instability. Wormholes, according to current theories, are not exactly the stable structures we'd like them to be. They could collapse at any moment, potentially resulting in a singularity, a point of infinite density. That's like going on a road trip and having the road disappear beneath you while you're still driving. Not an ideal scenario, is it? But don't lose heart, fellow travelers. The universe has a fascinating way of providing solutions to its own challenges. Enter exotic matter. This is not your everyday matter. Exotic matter has negative energy density and a large negative pressure. These peculiar properties mean that exotic matter could be the key to stabilizing wormholes, counteracting their tendency to collapse. Imagine filling a wormhole with exotic matter, like inflating a balloon with air. The negative pressure of the exotic matter would counterbalance the inward pull of gravity, keeping the wormhole open and making our journey possible. However, we must remember that this is all conjecture based on our current understanding of the universe. We have yet to detect a wormhole, let alone exotic matter. And even if we do find them, the challenge of harnessing these cosmic phenomena is another thing altogether. A voyage through a wormhole, thus, is a risky endeavor filled with uncertainties. But isn't that what makes the quest for knowledge so thrilling? The journey, they say, is more important than the destination. And what a journey it would be to ride the cosmic currents through a wormhole to another galaxy. Reaching the other side of a wormhole could mean stepping foot into an entirely different galaxy. Imagine the exhilaration of crossing the threshold of a wormhole and finding yourself in a completely alien cosmos, a place where the very laws of physics might behave differently. This is no longer the Milky Way we know and love, but a new, as yet uncharted galaxy, teeming with unexplored planets and stars. Just picture it, stars perhaps millions or billions of years older than our sun, shedding light on planets we've never seen before. Some of these celestial bodies could even be hospitable to life as we know it, or even more excitingly, they might harbor life forms that are completely alien to us, challenging our understanding of what life can be. Imagine the knowledge we could gain, the scientific breakthroughs that could occur. We could discover new elements, new materials, new forms of energy. We might find planets with atmospheres and ecosystems that could teach us about the past and future of our own planet. We could uncover the secrets of stellar evolution by observing stars at different stages of their life cycle. And who knows? We might even stumble upon civilizations far more advanced than ours, offering us a glimpse into the potential future of humanity. But it's not just about the potential for discovery, it's about the journey, the quest for knowledge, the spirit of exploration that has driven us since our earliest days. It's about pushing the boundaries of what we know and understand. It's about the unity that such a monumental achievement could bring. As we stand on the precipice of a new galaxy, we are no longer citizens of one nation or one world, but explorers of the universe. A wormhole could be our gateway to the cosmos, a chance to unravel the universe's deepest secrets. The idea of creating and traversing wormholes is thrilling, but what does reality say? Well, the reality, as we know it today, paints a rather different picture. Wormholes are still a theoretical concept, a beautiful mathematical solution within Einstein's theory of general relativity. They exist on paper in the complex equations of theoretical physicists, but we have yet to find empirical evidence of them in our universe. The current scientific consensus on wormholes is somewhat mixed. While they are mathematically possible, their existence in the physical universe is still a subject of ongoing debate. A significant challenge is the sheer scale of energy that would be required to create a wormhole. Some calculations suggest that the energy equivalent of an entire galaxy would be needed just to open a wormhole large enough for a single spacecraft to pass through. That's a staggering amount of energy, far beyond our current capabilities. Another challenge is the stability of wormholes. Theoretical models suggest that wormholes, once created, would be highly unstable, potentially collapsing in a fraction of a second. To keep a wormhole open long enough for any meaningful exploration, we would need a form of negative energy or exotic matter, which are still purely theoretical concepts themselves. Moreover, even if we could somehow create a stable wormhole and harness the colossal energy required, traversing through it presents its own set of challenges. The intense gravitational forces could potentially be lethal, and the journey itself might disrupt the wormhole, causing it to collapse. The lack of empirical evidence and the numerous theoretical challenges make the creation and traversal of wormholes a fascinating yet distant dream. It's a dream that continues to inspire scientists and science fiction writers alike, pushing the boundaries of our understanding and reminding us that the universe is far more strange and wonderful than we can possibly imagine. While we dream of cosmic shortcuts, the reality of wormholes remains confined to the chalkboards of theoretical physicists, at least for now. Wormholes, intergalactic travel, exotic matter, it's all part of the final frontier. We've embarked on an intellectual journey exploring the birth of a wormhole, the thrilling voyage through its cosmic throat, reaching out to another galaxy, and the harsh reality check that brings us back to Earth. Wormholes, as theoretical as they are, hold an irresistible allure. They represent the ultimate shortcut, a cosmic cheat code that could redefine intergalactic travel. Yet the challenges are numerous and substantial. We grapple with concepts of exotic matter, negative energy densities, and the immense technological advancements needed to manipulate such phenomena. It's a path fraught with uncertainties and unknowns, but one that could potentially unravel the fabric of our understanding of the universe. As we continue to probe the universe's mysteries, who knows what we might discover? Perhaps one day, we might just find our cosmic shortcut.